We are building the Fractals and Recursion program from the YByte Python curriculum available at www.ybyte.in. We have seen previously how we can use recursion to create, let's say, a pattern like this. But as we discussed, it looks quite simple. One wonders that why couldn't we just write a for loop with, let's say, adjusting the x and y coordinates and, the length of the square, the side of the square. Well, it turns out that, that is right. But with a little bit of a twist to what we have right now, you will see the real power of recursion coming out. So I suggest tighten your seatbelts and wait for what is going to happen next. Let's say instead of calling my square recursively only once, I call it a second time. This time round, I tell my second square to be on the left side of the first square. Now think through this carefully. Basically, we are asking one more square to be drawn on the left side. Remember, we had minus 100, minus 100, 200. Now this will call 50 minus 50, 100, which is the square to the right side. This will also go and call now square to the left side, minus 150, minus 50. And that's because minus 100 minus 200 by 4 is minus 150. So basically one square to the left. But let's see how this actually plays out. Like I said, tighten your seatbelts. Let's just call the same function again and see what we are unleashing. So I get my squares on the right, but look, it doesn't stop there. In fact, I end up getting a lot many squares, most likely more than what I thought about, more, through this pattern, because basically what happened is there is recursion going on and functions are calling themselves. So every square that gets drawn, remember, recursively calls a new square to be drawn both on the right side, the left side, until I get the, the base condition. And this is where the power of recursion really shows up, because not only are we having, let's say, a task which can be expressed in a smaller task, we are also creating some kind of nesting. We are doing this, let's say, repeatedly. Now, let's say I take this further and I say, okay, why don't I call this a third time? This time round, I'll bring it slightly down and I'll move it to, let's say, right of where I am. Now, these numbers are somewhat arbitrary, but you get the idea that I'm going to call this 3 times. Again, let's see what we have unleashed. It's actually quite amazing. When I look at this, notice everything looks like earlier, but there are a lot more squares being drawn. In fact, the pattern we are drawing is fairly intricate. Looks perhaps like grapes or perhaps like chandeliers. The point is, this is recursion, functions calling themselves in a very, let's say, nested manner. It is quite hard to imagine a single for loop or a nested for loop to do something like this. And this is where the real power of recursion is seen. Pattern is intricate. All we have done really is 2 extra lines of code. And that is where, it's so fascinating. This is recursion at its best, right? Let's, just for the sake of completion, let's go back to the 2-level recursion, but this time round, call the recursion before the function is drawn. And this is quite interesting. We're going to analyze this later carefully. When I do this, when I, let's say, run this piece of code, notice the effect of inverting those two is quite tremendous. I end up drawing from the bottom up to the bigger square. So notice the smaller squares are being drawn first. Smaller square, and then finally I get the bigger square. Let's just include the third one also in this reverse manner. So when I run this, for example, notice my smaller squares are getting drawn first, the bigger square is yet to be seen, but eventually I'll end up with the same pattern. And this is really amazing. Like I said, now is where the power of recursion is really visible. It looks quite amazing that we have unleashed something which is doing so much work for us. And this is happening because we are recursively calling the function. We are going to analyze this in great detail. Exactly how do all these squares come up? What exactly is going on? But for now, let's just look at this, and let's say just enjoy the process, right? It's just so beautiful. Look, the whole thing is being created from, let's say, bottom up because of the way it's being recursed. I get the biggest square and I'm done. I hope this has been interesting to you. This has been thought-provoking to you. Like I said, in the subsequent videos, we'll analyze this in detail as to why is this working and, what exactly is going on. In general, if you like this way of learning, look at our website, www.ybyte.in, because we learn Python programming through such fun activities. Take care. Thank you so much. Bye-bye.